Hi everyone, today we are going to continue our factoring unit and we're going to learn another method of factoring polynomials. And this method is called grouping. So it's actually very different than what we've been working on for the past week or so. So just to review, because we've learned lots of different methods of factoring now. Just to review, so far, in order to factor a polynomial, we have learned how to factor out a greatest common factor. So that's one way of factoring. And again, that's something like this, 2x squared plus 10x. Both of these terms have a common factor, right? You can pull out a GCF by figuring out what would go into both of these. So that's one method of factoring. And again, the factored version of that would be, we could do 2x on the outside, and then we would have x plus 5 left over on the inside. So that was the first method we learned. Then we learned how to factor trinomials. And remember that trinomials have 3 terms. So we factored something like this, x squared plus 3x plus 2. And remember that trinomials, when you factor them, they factor into 2 binomials, right? So binomials have 2 terms, and in this case, this would factor into x plus 2 and x plus 1, because 2 times 1 is 2, and if you add these together, it equals 3. So we've learned trinomials, and trinomials are just factored in this format. Then we learned how to factor trinomials that have a GCF in front of them, or a GCF to take out first. So that's what we learned in the previous video from the other day. So trinomials with a GCF. It's basically these 2 topics combined, right? So if we had something like this, 5x squared plus 15x plus 10, there would actually be 2 steps to factor this, right? So we pull out the GCF first. So 5 goes into all of those. And then we would go ahead and factor the trinomial like normal. So then it would turn into something like this. And I'm doing these really quickly, but it's just because we're reviewing the 3 methods that we learned. So that's what we know so far as factoring goes. We know how to take out a GCF, we know how to factor a trinomial, and we now know how to factor a trinomial that has a GCF to take out first. So those are the 3 things we've learned so far. Now we are going to learn a method called grouping, which actually is not a trinomial. So we're taking a break from trinomials for a second. It is where you factor something that has 4 terms. So something, and I'm just kind of making this up in my head, something that looks like this. We're going to be able to factor stuff that has 4 terms. All right, so that's what we're going to learn how to do today. So 4-term polynomials. They don't have a fancy name like trinomial or anything like that. We're just going to call them polynomials with 4 terms. So you can factor polynomials that have 4 terms with a method called grouping. So we're going to go ahead and walk through how to do this. So the first thing that you want to do is group the first 2 terms together and the last 2 terms together. And you're just going to group them using parentheses. So in the first example here, I'm just going to put parentheses around those first 2 terms and parentheses around those last 2 terms. Notice how I included that symbol in front of the 2. It's always a good idea to do that, and you'll see why in just a little bit. So I just grouped these first 2 together, and I grouped these last 2 together. And then what you're going to do is basically treat each group separately. You're going to factor out the GCF from each of those binomials that you just created. So I'm going to zoom in here so you can see what I'm talking about. So let's take a look at just this first binomial for a second. So kind of ignore the rest of that. What would be the GCF of those 2 terms? And let's think about that. Well, there's only a 1 right here, so there's not a number really that goes into both of these, right, besides 1. But they do both have x's. So how many x's could I take out? What would be the greatest amount of x's I could take out? And it looks like I could take 2 of them out because this one says x squared. So that would be the greatest common factor of that first group. So the GCF of this first group is x squared. So let's go ahead and take that out. So we're going to write that on the outside. So x squared. And then what would be left on the inside? And again, we're kind of just ignoring this part over here for right now. We're only looking at this part. If I take x squared out of these 2 terms, well, in the first term, I would just have 1x left over. And in the second term, if I take x squared out, then I would only have the 7 left over. So I'm going to write plus 7. Okay, so that first part is done. Now I'm going to zoom into the other group. So let's take a look at this other group over here. So again, we're only looking at this part. What's the greatest common factor of those two terms? Well, let's see, 2x and 14. Well, the 14 does not have an x, so I can't take an x, but 2 goes into both of these numbers, right? So I can definitely take the 2. So GCF of this one would be positive 2. So let's go ahead and take that out. We're going to take out the positive. Now I'm going to put positive 2, and there's a reason why. We're going to take out positive 2. I'm going to write the plus sign, plus 2. And then in parentheses, what do we have left over? Well, 2x divided by 2. If I take the 2 out, the only thing I would have left is an x. And if I divide 14 by 2, 14 divided by 2 is 7. So I'm going to write plus 7. All right, so let's take a look at what we have now. Now, I know this looks kind of weird, right? So we turned this 4-term polynomial into this crazy thing with these parentheses, right? And the reason why we did that, you should notice that the parentheses, so these numbers in the parentheses here, this factor, these are actually the same exact thing, right? X plus 7, x plus 7. And that's actually what you want to happen. So as long as you end up with matching parentheses here, that is exactly what's supposed to happen. So that means you're on the right track. Now, the reason why we did this, now that they have a common factor, so like this side has a common factor with this side, this x plus 7 and this x plus 7 are exactly the same thing, you can factor out that common binomial. So step 3, it says factor out the common binomial. All that means is you're going to remove it from both of those sides. So I'm going to go ahead and pull it out here. I'm going to put x plus 7 right here. Now, if I remove 7 from this blue part, if I remove x plus 7, the only thing I would have left is x squared. So in my other factor, my other binomial here, I'm going to start it by putting x squared. If I remove the x plus 7 from the purple side here, so if I remove that x plus 7, the only thing I would have left is plus 2 or positive 2. So I'm going to finish this off by writing plus 2. So we've actually just factored this polynomial. We're all done. We've got our two factors here. We've got this binomial and we've got this binomial. And again, the way that we would fill these in, one of your parentheses is going to be whatever's in this matching part here. So whatever this says that matches up with this one, we're just going to write that as one of our factors. And then the other one, we just take whatever's left over on the outside here. So this outside part goes in the other factor. Now, some people prefer to write the x plus 7 first. I've seen it both ways. So you could write it like this, x plus 7, and then the other one could be your x squared plus 2. It does not matter which order that you write them. But that's how you factor by grouping. Now, we're going to do a lot of examples of this because I know it's very different than what we've been doing. But this is the basic process. So again, you start by grouping them together with parentheses. You pull out the GCF from both groups, and then you write out your two factors. Now, if you wanted to check your work, so if you want to check to make sure we did it right, or if you just want to see like, why does this work? Is this going to actually work out to be what it should be? You can go ahead and just distribute this like we normally would do. So let's do that real quick. X squared times x, well, that's x cubed. X squared times 7 is 7x squared. And then if I do the 2 times x is 2x, and 2 times 7 is 14. Now, normally, we could combine the middle terms, but we actually can't in this case because that is 7x squared, and that's just a regular 2x. So you can't combine those. So this would actually be how we would leave it. And if you look at the original problem, that is exactly what it started as, right? So that means we did it correctly. All right, so we're just going to go ahead and do some more examples. Okay, so I'm going to walk you through all the steps again. So on the first example, the first thing you always want to do is group them with parentheses. So we're going to put parentheses around these first two terms, and we'll put parentheses around the second two terms. And now you want to take a look at each group separately. So we're going to start with this first group here, the one I'm underlining in blue. So let's take a look at those two terms. What would be the greatest common factor? And again, we're only looking at these two terms here. What would be the greatest common factor there? Well, I can't take out any number, right? This is a coefficient of 1, so I don't really have a GCF there, but they do both have x's, right? So what's the most that I can take out? The most that I can take out is 2 of them, so we're going to put x squared on the outside. And then what would we have left? Well, let's see. If I divide this by x squared, I would just have x left over. If I divide this by x squared, well, those would cancel, and I would just have the positive 4. So I'm going to write plus 4. Okay, so that part's done. Now let's take a look at the other group. So this one that I'm underlining in purple here. What would be the greatest common factor of those two terms? So again, we're only looking at these two pieces here. And it looks like, let's see, does 8 work? Would 8 go into both of these? And yeah, it looks like that works, right? Now we can't take an x because the other term doesn't have an x, but I can definitely take out the 8. And we're going to take out a positive 8 because the leading number is positive. So we're going to write plus 8. You always want to write this plus sign just because it makes it a little bit more organized. We're going to write plus 8. And then let's see what we would have left over. If I divide this by 8, I'm only going to have an x left over. If I divide this by 8, well, that equals positive 4. And you can tell right away that we're doing it correctly because we ended up with matching numbers here. If you're doing this and you end up with different things in your parentheses, then you know you went wrong somewhere. Okay, the last step is to fill out your 2 factors. So we should have 2 binomials. So I'm going to go ahead and set up my parentheses here. And it doesn't really matter what order you do this, as long as you put the right ones together. In one set of your parentheses, you're going to write whatever was on the outside here. So this x squared plus 8, that's going to go in one of your parentheses, x squared plus 8. And in the other set, you are going to write whatever they had in common. So this x plus 4, we're going to go ahead and write that in the other set of parentheses. And that would be completely factored. So that's it. Now, again, you could switch the order if you want to. I'm not going to keep saying that every time, but just you should always know that that's okay. So you can switch the order of these if you want to. You could have written it as x plus 4 in the front and then x squared plus 8 in the back. That's totally fine. So either one of these are fine. All right, let's take a look at that next example. So same thing. We're going to follow the same process for all these. First step is to group them together. So first 2 terms and the last 2 terms. And then we're going to take a look at each side here. So let's look at that first part. What can we take out of both of those terms? So the greatest common factor here, it looks like we can take out a squared because they both have at least 2 a's, right? So we're going to take out a squared. And then we're going to write down what we would have left. If I divide this by a squared, well, I would only have 1 a left over. And if I divide this by a squared, well, those would cancel and I would have a positive 2 left over. Okay, in the next part, let's see what we can take out of that. So again, we're looking at this side now. What would be the greatest common factor there? What goes into both of those numbers? Well, it looks like positive 9. So we're going to put plus 9. And then we're just going to divide both of these by 9 and see what we have left. So in the first term, we would just have a. In the second term, we would have plus 2 because 18 divided by 9 is 2. And look at that, we did it correctly because we have the same thing in here in our parentheses. So let's go ahead and write out our 2 factors. And again, I usually put this one first. I usually put these outside terms in first. So a squared plus 9 would go in one of them. And in the other one, we're going to put whatever they have in common. So that a plus 2. All right, let's look at the next one. Okay, we're going to start it the same way. So we're going to go ahead and group these together. And the first part's just kind of normal, right? They all were kind of like this for that first part. So if I look at that greatest common factor, again, it would only be the w's, right? I can't take out any numbers because there's just a 1 right here. So we're going to take out some w's. And it looks like I can take 2 of them again. So we're going to put w squared on the outside. And then if I divide by w squared here, I would have 1 w left over. If I divide by w squared here, I would just have positive 5. All right. Now this next part, you got to be careful with negatives, Remember, we talked about this in the last video. If the leading coefficient, so if that first number is negative, you need to take out the negative. So it's just always standard. We always take out the negative if that first number is negative. It doesn't matter about the second term, only if that first term is negative. So in this case, the first term is a -8. So I'm definitely going to take out a negative. Now, can I take out the 8? Is that the GCF? Does 8 go into 40? Yes, it does. 8 goes into 40. So let's take out -8, and then we're going to write down what we would have left. So if I take out -8 from -8w, what would I have left? So -8, well, those would just cancel out, and I would have a positive w left over, right? If I take out -8, or if I divide -8 into -40, let's see, what is -40 divided by -8? Well, remember, a negative divided by a negative is a positive. So this would turn into +5 because 40 divided by 8 is 5. And that's exactly what we should have ended up with because these are supposed to match up. And they do, so that's perfect. So let's go ahead and write out our two factors here. So in the first one, I'm going to put whatever was on the outsides, which is our w squared minus 8. And in the second one, I'm going to put that w plus 5. All right, and the last example here. So let's take a look at this one. Same thing, let's go ahead and group them. So we're going to group the first two, group the last two. And let's look at the first group. So what's the greatest common factor here? How many p's can I take out? Well, it looks like this time I can actually take out 3 of them, right? So we're going to take p to the third on the outside, and then we're going to write down what we would have left. So if I divide the first one by p to the third, I would have 2 of them left over, so p squared. And if I divide the second one by p to the third, well, the only thing I would have left over is that -6, so -6. All right, in the second group, let's take a look at that. So what's the greatest common factor here? Well, once again, we have a negative in the front, which means I do need to take out the negative. So I'm definitely taking out the negative. And then let's see about this 2. Does 2 go into both of these? Yes, it does. So we're going to take out the 2. So -2. And then we're going to write down what we would have left. So we're just going to divide each of these by -2. So in the first term, those would cancel, and I would just have p squared. In the second term, we're dividing by -2, so be careful with that. Remember that a positive divided by a negative is a negative. So 12 divided by -2, that's -6. So I'm going to write that as -6. And they match up, which is exactly what's supposed to happen. So let's go ahead and write in our two factors. So in the first one, I'm going to put the outside numbers here. So p to the third minus 2. And in the second one, we're going to put that factor that they had in common, p squared minus 6. Okay, we only have a few more examples left. So let's go ahead and do these last few. All right, in this first one, let's go ahead and group them together. And then let's do the GCF of the first side. So GCF here, well, this time we have a number in front. And we do it the same way, right? We want to see, is there a greatest common factor between 3 and 21? And yes, there is. 3 goes into both of those. So I'm definitely going to take the 3. And then can we take any x's? And yeah, it looks like we can, right? They both have x's. So I can take 2 of them because that second term has 2 of them. So I'm going to put 3x squared on the outside. And then I'm going to write down what I would have left. So let's go ahead and figure that out. So 3x cubed divided by 3x squared. Well, the 3's would cancel, and I would have 1x left over. All right, in the next term, we're going to divide by 3x squared. The x's would cancel, and 21 divided by 3 is 7. So we're going to write -7. All right, so let's find the GCF of the second group. So let's go ahead and take a look at that. Let's see, I can't take any x's because this doesn't have an x, but 4 goes into both of those, right? So we're going to take out the 4. So we're going to do +4. And then if I divide each of those by 4, I would have x left over here, and 28 divided by 4 is 7, so x minus 7. And we did it correctly because they match up, x minus 7, x minus 7. So let's go ahead and write our two factors. In the first one, I'm going to put the outside numbers, so 3x squared plus 4. And in the second one, I'm going to put x minus 7. All right, and this one over here. So same thing, let's go ahead and group them up. And then let's find the GCF. So GCF of the first part. Well, let's see. What goes into 16 and 8? And it looks like the greatest common factor of 16 and 8, well, that would be 8, right? 8 goes into both of those. And we can also take out 2 of the x's. So we're going to take out x squared. And then let's see what we have left. So we're going to divide each of these by 8x squared. All right, 16 divided by 8 is 2. And then I would also have 1x left over here. So that would become 2x. And then over here, everything cancels. And remember what that means. That actually means it equals 1, right? When you divide something by itself, it equals 1. So we're just going to put plus 1 right here. All right, and then let's take out the GCF of the second part. So let's see, it is a negative, right? So we do have to take out the negative. Now we can't take out the negative 6 because 6 does not go into 3, but 3 would work, right? 3 goes into 3 and 3 goes into 6. So we're going to take out negative 3, and then we're going to see what we would have left. So we're going to divide both of these by negative 3, and be careful with your negatives here. So in the first term, remember when you do negative divided by negative, it's a positive. So this is going to become positive 2x because 6 divided by 3 is 2. So positive 2x. And then over here, negative 3 divided by negative 3, well, that equals positive 1. All right, and we did this correctly because they match up. So let's go ahead and write our factors. So we would have 8x squared minus 3 in one of them. And then in the other one, we would have the 2x plus 1. All right, and then we have two more examples that are just a little bit different. It's the same process, but you're going to find that sometimes you won't be able to see a GCF in one of your groups. And that's because you're just going to have to take out a 1 or a negative 1. So you'll see what I'm talking about in just a second. Let's go ahead and do this one. So let's group these like we normally would do. So in the first part, it's actually just normal. We do have a GCF here. So the greatest common factor there would be 9, and we could also take out 2 of the y's. So 9y squared, and then let's see what we would have left. If I divide by 9y squared, well, I would just have 1 of those y's left over. And over here, if I divide by 9y squared, the y's would cancel, and 18 divided by 9 is 2. So this would become y plus 2. Now, if you look at that second group, it doesn't look like there is a greatest common factor, right? Because there's no number, there's just a 1 here, right? There's nothing that goes into both of these. But we still have to take something out because that's how you do this method of grouping. So anytime this happens, if you can't take out anything, then just take out a 1. So we're going to take out a positive 1. Because when you take out a 1, nothing really happens, right? If you divide this by 1, it's still going to be y. If you divide this by 1, it's still going to be 2. So y plus 2. And this actually is correct because if you see what we got left, they do still match up. So anytime that happens, if you end up with a group that just doesn't have a GCF, just take out a 1. All right, let's write our two factors. So in one of them, we're going to have the outside terms here, 9y squared plus 1. And then in the other one, I'm going to put y plus 2. All right, and the last example is very similar. So let's go ahead and group these together. And then let's find the GCF. Okay, in the first one, let's see. What goes into 6 and 21? Well, it looks like 3 is going to be the only number that works for that, right? 3 goes into 6, and 3 also goes into 21. And then we can also take out the p squared, 2 of the p's. So then let's write what we would have left. Well, 6 divided by 3 is 2. And if I take out the 2 of the p's, I would have 1 left over. So 2p. And then over here, if I divide by 3p squared, the p's cancel, and I would just be left with a positive 7. 21 divided by 3 is 7. All right, now if you look at the second group, it's kind of similar to the previous one. There's not really a GCF. However, that first term is negative. So you do want to take out the negative. So we're going to take out the negative, and technically we're taking out a -1. Anytime you take out a negative by itself like that, you're really taking out a -1. So we're going to write -1 on the outside, and then we're just going to divide both of these by a -1. And all that's going to happen is that these are going to become positive, right? If you divide by -1 here, it's just going to become positive. Same thing over here, that's just going to become positive. So this is going to become 2p plus 7, which is exactly what we wanted it to become, right? They match up, so that's perfect. So then our two factors would be 3p squared minus 1, and then the 2p plus 7. Okay, and that is it for this video. Let me know if you guys have any questions, and I will see you next time. Bye.